All right, let's learn to count. We have a bag containing 12 numbered marbles. So I can tell the difference between all of the marbles based on their number. And we've grouped them together also by color. There's 4 blue, 6 red, and 2 white. Number 1. How many ways can we pull 5 marbles from the bag with replacement? So if I'm pulling 5 times, 1, 2, 3, 4, 5, the first time I've got 12 marbles in the bag to choose from. So there's 12 different possibilities there. Now, if I replace it, then I also have 12 different marbles to choose from for the next time. And on the third pull, I also have 12, right? I'm replacing the marble every time. So I've got 12 different options for all of my 5 different pulls. So I've got 12 to the 5th different ways to pull these marbles. That comes out to about 248,832. All right, how many ways can we pull 5 marbles from the bag without replacement if the order matters? So we've got 12 marbles in the bag and we're arranging or permuting 5 of them, right? We care about the order. So if I were to pull all 12 marbles, there's 12 factorial ways to do that. And I'm only pulling 5 of them, so I want to ignore the 12 minus 5, or the 7 factorial ways to arrange the 7 marbles that I don't pull. And so 12 factorial, that gives us about 479001600. 12 minus 5, that's 7. 7 factorial is 540. Right, so I'll note here, our factorial is n times n minus 1 times n minus 2, all the way down the line until you hit 1. Right, or technically 0 factorial, but that's defined to be 1, so it doesn't change. Right, so that numerator is just 12 times 11 times 10 times 9 times 8 times 6 times 5, all the way down. Right, so if we do this, what do we get? 12 factorial divided by 7 factorial, get 95,040 ways to do that. Number 3, how many ways can we pull 5 marbles? So from the 12, we're pulling 5 marbles, and this time order does not matter. So we're just combining or counting the 5 marbles from the 12. So the equation is set up almost the exact same way. There's 12 factorial different ways to arrange all 12 marbles. We want to ignore the 7 that we're not picking. So there's 12 minus 5, there's 7 factorial ways to arrange those 7 marbles. But then this time we also want to ignore the 5 factorial ways to arrange the marbles that we pick, because we don't care about how they're arranged. We're just counting. So when you get this down, 479001600, that was number of ways to arrange 12 objects. The number of ways to arrange 7 objects was 5,040. And then the number of ways to arrange 5 objects is 120. So 12 choose 5, there's 792 ways to do that. All right, number 4. Number 4 says, how many ways can we pull all 12 marbles from the bag if we ignore the numbers? So if we can only tell the difference between the marbles if they're different colors. So we set up the equation in the same way. There's 12 factorial ways to pull all 12 marbles. But this time, if I pull the first blue and then the second blue, it doesn't matter because I can't tell the difference between me pulling that or me pulling the second blue and then the first blue. Right, so I need to ignore all the different ways that I can arrange the 4 blue marbles. And there's 4 factorial ways to arrange the 4 blue marbles. Right? Also, I can't tell the difference between all the red marbles. And there's 6 factorial ways to arrange 6 red marbles. There's 2 factorial ways to arrange the 2 white marbles. So when you get this done, the number of ways to pull all 12 marbles from the bag, if you ignore order, should be 13,860.